What do zip files, MP3s, and JPEGs have in common? They all rely on data compression, and one of the most efficient algorithms behind it is Huffman Coding. Want to learn how this algorithm shrinks your files while preserving every single bit of information? Let's break it down simply, with a story, a tree, and a secret code. Introduction. Welcome to EduAIverse, where we make complex computer science topics easy and enjoyable. Today's focus is on Huffman Coding, a greedy algorithm that plays a huge role in data compression, and you will learn how to build a Huffman tree from scratch, with real examples. 1. What is Huffman Coding? A lossless data compression algorithm. Assigns shorter codes to more frequent characters and longer codes to less frequent ones. Keyword: greedy approach. 2. Real-life analogy. Morse code or texting. 130, 230. Imagine you send texts with limited characters. Would you type OK as OK every time? What if O to 0, K 1? More efficient, right? Huffman Coding does something similar. It saves bits based on frequency. 3. Why it works. The greedy principle, always combine the two smallest trees, ensures minimal weighted path length. This greedy choice results in optimal binary prefix codes. 4. Application areas used in zip compression, JPEG, MP3 file encoding, network protocols, embedded systems with limited memory, also important in competitive programming and interviews. 5. Bonus. Tip: common mistake. Don't confuse Huffman Coding with fixed-length encoding. Huffman ensures no code is a prefix of another prefix-free property, making it uniquely decodable. Conclusion: Huffman Coding is a brilliant example of how greedy algorithms can create optimal solutions. It's not just theory, it powers real-world apps you use every day, and now you understand how it works. If you found this explanation helpful, give it a thumbs up, subscribe to EduAIverse, and share it with your friends. And in the comments, tell us, what other algorithm should we break down next?